All right, I'm starting test B, the second half of this test, number 15. So we wanted to solve by taking the square root of both sides. Now, you could either recognize that this thing can be factored, or you could do it by completing the square. So I'll do it both ways. If I realize this thing can be factored, I'm going to multiply A times C. So I get 9 times 25, and what factors of that add up to 30? Well, I think it's going to be 15 times 15 because it's 225. So I have 9x squared plus 15x plus 15x plus 25. Still leaving that 44 over there. Factoring by grouping, I can pull out a 3 and an x. I'm left with a 3x plus 5. Over here, I can pull out a 5, left with 3x plus 5. Notice, 3x plus 5, 3x plus 5 equals 44. So we are now at this 3x plus 5 squared equals 44. Take the square root of both sides, and we get 3x plus 5 equals a positive negative square root of 44. Well, 44 can be broken up into 4 times 11, so that would be positive or negative 2 square root 11. All right, so we have to subtract 5 from each side, and remember, I always tack that on the front, so we don't end up combining it somehow with that. And then I divide by 3. Those are my two solutions of this. Okay? Now, if I go back and I want to complete the square, this is what we're going to do. We'll get to the same answer. All right, I'm going to subtract the 25 over because that's what I have to do first. 9x squared plus 30x equals 19. I can never complete the square with anything but a 1 there, so I have to factor out the 9. So this becomes 30 over 9, which is 10 over 3x. All right, now b is 10 over 3, divided by 2, same as multiplying by 1/2. This becomes 10 over 6, which is 5 over 3 squared, plus 25 over 9. Now, I'm going to add 25 over 9 times this 9 over here. Notice what happens. Those cancel out, so I'm really back at 44, aren't I? So this is 9, and this becomes x plus b over 2, 10 over 6, which is 5/3 squared. Divide by 9, divide by 9. Take the square root, x plus 5 over 3 equals positive and negative. Square root of 44, which we said is 2 square root 11, square root of 9 is 3. Subtract 5/3. Becomes negative 5 over 3 plus or minus 2 square root of 11 over 3. Same answer. Okay? So you could have done it either way. Now, here, I'm telling you to complete the square. All right? 4x squared plus 8x, I'm going to move that 1 over, equals 17. I have to factor out the 4. So this is what I'm working on. So b is 2. b over 1, I'm sorry, b over 2, 2 over 2 is 1, times 1 is 1. But I'm really adding 4 over here, aren't I? So this is equals 21. This becomes 4. X plus 1 squared equals 21. Divide by 4. Take the square root of both sides. X plus 1 equals plus or minus square root of 21. Square root of 4 is 2, isn't it? So now I'm going to subtract 1 from both sides. I tack it on the front. This is what the answer looks like. All right, I told you to complete the square, you have to follow the process. In this part, you absolutely cannot complete the square when there's something other than a 1 in front of that x squared. You must factor it out. All right, moving on. solve using the quadratic formula. What's the quadratic formula? Minus b. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. All right, b is negative 5. So I'm going to say 5 plus or minus the square root of 25 minus 4 times 2 times c all over 2a, which is 4. Now notice, we're subtracting and we have a negative. 4 times 2 is 8, times 2 is 16. We're going to be adding 25 plus 16 there, aren't we? 25 plus 16 gives me 41. So this becomes 5 plus or minus the square root of 41 over 4. I do not believe we can simplify that at all. Let's see. 4ac. There are my answers right there. All right. Now this says solve this inequality by using your graphing calculator. Just like an equality, we have to get this equal to 0 or less than or equal to 0 or greater than or equal to 0. So I have to add 3 to both sides. Now notice, we've got to put those terms together. 4x squared plus 14x plus 3 is greater than or equal to 0. So if we go to our calculator and we put it in, we get 4x squared plus 14x plus 3. Now I'm graphing the boundary condition, right? And this thing, I don't have to sketch it, but I'm going to. What you end up with is something that looks like this. So I'm going to use my second calc 0 function on the calculator to find those points. That's why we learned how to do this. All right, we have to do left bound, right bound guess. And the first one is negative 0.23. And over here, let's find this one, second trace 0. Coming all the way over, because I gotta get to the left of it, left bound, right bound, guess. This is negative 3.27. So these are part of our inequalities, right? We have to decide if this part of the x-axis is our solution or the outsides. So let's test a point. I'm going to test 0, 0, right there. It is outside of here. So if I put 0 in, I get 0 plus 0, 3. 3 is indeed greater than 0. So I know this is part of my solution. Just for fun, I'm going to test something over here. I'll test negative 4. So negative 4 squared is 16 plus 14 times negative 4 plus 3. So let's test it. 4 times 16. I'll be subtracting 14 times 4, won't I? Which is all still positive, so I'm still greater than 0. So this is going to be part of our solution. I'm just going to double check this, and I will use a negative 2. So if I come here and I plug in a negative 2, negative 2 squared is 4, plus 14 times negative 2 plus 3. Notice 4 times 4 is 16, minus 28 is negative, so this is not our solution set in here. So if we look at this, x has to be less than this number, and this is or equal to, because that's including, right? Or greater than this number, or equal to. There, you never can write a compound inequality with the signs going in the opposite directions. This is the process, folks. You have to get the boundary, then you have to test some points to make sure you know what part of the x-axis are our solutions. Anytime you're finding solutions for inequalities, you're looking at the x-axis. That's why this number right there, we always have y equal to 0, don't we? Because that, we're looking for the parts of the x-axis, the x-intercepts that are our solutions. Moving on. This says solve this algebraically. This one was supposed to be very simple, which means you had to be able to factor it. And if I look at it, what factors of negative 18 add up to 3? This is what I have, right? So x, in this case, is equal to -6, x is equal to 3. What I'm doing there is I'm finding where this quadratic hits the axis. So it's at -6 and it's at 3. Now, those are not included, so -6 and 3. We need to figure out which part of this x-axis is our solution. Test a point. I'm going to test good old 0, 0. If I put in 0 here, 0 minus 0 minus 18 is less than 0. That's true. So I'm thinking this is what I have. But I want to double check. I'm going to come out here and test 4. 4 squared is 16 minus 3 times 4 is 12 minus 18. That is... All right, I found a mistake, and I apologize. So what we have here is this. These factors end up to be this. I did not double check them, did I? So x is 6 or x is -3. So let's just kind of, we said -3 or 6. So 0, 0 still tells us the center's in here. But let's test 7, for instance. So 7 times 7 is 49. Yeah, that one must, that's how I figured out I had a problem. 49 minus 3 times 7 is 21 minus 18. Guess what? That is not less than 0. So it's no over here. Let's test -4. -4 times -4 is 16 minus 3 times -4, which is adding 12. 16 plus 12 is 28, right? Minus 18. So that's positive. So this is a no. So our answer has to be x is greater than -3 and less than 6. All right, sorry for the snafu on that one. But you see, when I'm checking points, that allowed me to figure out I had a problem, right? Figure out I had a problem, and I had to go back and verify it. Now, this says write the quadratic function in vertex form. Y equals a, x minus h squared plus k, where the vertex is hk. This additional point, folks, is only there to help us solve for a. So first we have to plug in y equals a. X minus a -4 is x plus 4 squared minus 2. Now take that additional point right here to help us solve for a. -1 equals a. -3 plus 4 squared minus 2. -3 plus 4 is 1. So -1 equals 1a minus 2, add 2 to both sides, a equals 1. Now your final equation, folks, has to have an x and a y in it. It's a function. We're not asking at only one specific point. It has to have the x and the y. You go back. Now you know a is 1. You know from the vertex the part that goes here, and that is your answer. The vertex tells you hk. The additional point allows you to solve for a. Now, intercept form, y equals a, x minus p, x minus q, where p and q are the intercepts, right? These problems, again, weren't meant to be anything too terrible. But why? I'm going to plug in x minus my first intercept, -4. X minus my second intercept, 1. So right now it's y equals a, x plus 4, x minus 1. The additional point I will plug in only to solve for a. -4 equals a, -3 plus 4, -3 minus 1. A, -3 plus 4 is 1. -3 minus 4 is -4. -4 equals -4a. A equals 1. Now I take the a, and it goes back into that equation. Y equals 1, which you don't need to write. Okay. And that's the end. So we'll have all these problems to go through so you're ready for the retest. All right, thanks.